Thank you. And I'd like to apologise in advance if at any point I seem to get a bit vague and then start snoring, because a little part of my head still thinks it's about 11:05 at night. Wrong time zone issue. When Deb invited me here today, I sort of asked what sort of audience I'd be talking to, and she said, 20-something engineering students. So I have no idea what to say to an audience presentation, lecture, the rest of it. So I'm not going to try and measure up to Steven Pinker. I'm just going to wibble a bit until I fall asleep here, or you can ask me questions and keep me awake. Should have thought to bring an electric cattle prod or a taser or something so you can wake me up. Okay, I'm not going to try my luck with that one any further. As Deb says, I'm a science fiction writer by trade. I have another t-shirt which unfortunately is dirty because I used it for the last bunch of students I spoke to yesterday, which has my job description on it. I tell lies for money. It's very important that you bear that in mind whenever anybody points to a pundit, and particularly a science fiction author, bloviating about the future. Bear in mind that science fiction is, when we get down to it, fiction. Although fiction in general is the study of the human condition through creative and interesting lies. We're talking about things that don't actually happen, but that shed insight into human minds, human personalities, human lives. Science fiction traditionally tends to be rather nuts and bolts oriented and pays a lot of attention to what Richard Dawkins calls the extended phenotype, our technological and constructed environment that we've made around us, including aspects of that environment that don't actually exist yet. 1 second. One of the things that draws me to science fiction is you're allowed to explore areas within it, implications of new technologies, including the second-order consequences of introducing them. In a way that just isn't really acceptable in your traditional mainstream literary fiction. One could argue actually that any modern work of fiction that doesn't include in the background implicitly the internet, cheap international jet travel, global climate change, and I don't know, the popularity of cat videos on YouTube is actually a historical work of fiction. It doesn't discuss the world as we experience it today. Much less does it tell us anything useful about the world as it's going to be in 30 years' time. I would hope, looking around here, that everybody in this room will still be alive in 30 years. So what is the world of, say, 2043 going to look like? As a science fiction writer, that's one of the things I have to think about, especially if I'm trying to set a fiction that far out. Now, one of the sneaky tricks of the trade is that I don't actually do that if I can possibly avoid it. It's really, really easy to write science fiction set 500 or 5,000 years in the future. It's reasonably easy to write science fiction set 5 years in the future. You look at Intel's chip roadmap for the next 3 years, extrapolate a little bit, and there you go. You also want to throw in a couple of black swans. I mean, who in 2000 would have believed you if you'd written a novel set in 2010 in which the World Trade Centers had been demolished by terrorists and we'd invaded 3 different Middle Eastern countries with disastrous failures as a result? But, you know, you throw in a bit of stuff like that that nobody will believe. And there you have it. There you've got the near future. 30 years in the future is really difficult. The reason it's difficult is because we're off the actual short-term roadmaps, but we're not far enough away that people can say the question of how we get there from here doesn't apply. So, to extemporise, let me take a few guesses at what the world of 2043 is going to look like. Firstly, economics, development and trade. There have been some very interesting things happening in the past decade or two. In fact, since about 1986, when the leaders of the Chinese Communist Party made the very interesting decision that they were going to try to liberalise and in the economic sense and allow a whole bunch of free market reforms. We are living through a really unprecedented period in which the population of the developed world effectively triples in a period of about 1 generation. This is with both China and India experiencing sustained economic growth at an average rate of over 10% per annum. Obviously this isn't going to go on forever, It's already causing severe environmental degradation. I don't know how many of you saw the news about Beijing's air pollution this month, but it's so far off the scale they had to extend the scale to make it fit. But it is very significant. It has long-term implications for our energy budget, for the rate at which global climate change is going to get worse, for diplomatic issues, for raw material flows around the world. And there's more to come. The picture of the rest of the world we get through the media in the United States and in the European Union is a bit warped and distorted. Africa, for example, is frequently portrayed as very, very backward, desperately poor, mired in war, all sorts of horrible things happening. If you've been reading the recent news, there's interventions by France, the United Kingdom, and the United States in Mali against Islamicist rebels. You'd think Africa was a complete disaster area and a basket case. In actual fact, the African continent as a whole, which has over 1 billion people and 43 nations in it, is very heterogeneous, has averaged just under 7% annual compound growth for a decade. This is despite also having the tail end of the Congo Wars, which were the most violent wars since the First World War and Second World War, dwarfing the Vietnam War or the Korean War in terms of bloodshed. Yes, parts of Africa are doing really, really badly, but overall, the poverty of Africa today is not the poverty of Europe in the wake of the 30 Years' War of the 17th century, as it was 2 decades ago. It's more like the poverty of Europe in the 1850s. By today's standards, by today's developed world standards, they're poor. By their own standards, they've never had it so good. And furthermore, if this overall level of development continues, in about 10 to 15 years, just as the Chinese and Indian economic development curves are peaking, as they're running into the demographic issues of the one-child per family policy in China, which will result in the ratio of workers to pensioners dropping like a stone, there'll be a point at which China can't continue developing. Just as China and India are maxing out on the development curve, have caught up, Africa will be poised to do the takeoff as well. The way I see it, if we can cope with our environmental degradation issues, our energy problems, and the energy problem is a huge one, and also our pollution issues, then by the middle of this century we will be looking at a world that is predominantly developed, so that pretty much everybody, with the exception of a few failed states, will enjoy the living of, at the very least, somebody in East Germany in the 1970s, which may look pretty dismal. 1 car per 20 families, telephones tapped with the secret police and not many of them. But on the other hand, compared to dirt-floored huts, it is, and subsistence agriculture is something else. So we're looking at a potentially an increasingly prosperous world. Now, the energy issue is a major one because that's tied intimately to climate change. Ultimately, we cannot go on increasing our energy usage globally on an indefinite basis. If for no other reason, even if we weaned ourselves off fossil fuels, stopped emitting carbon, we can't keep on pumping out more energy indefinitely because eventually we'll fry in our own waste heat. Admittedly, we've got about 3 orders of magnitude of headroom before that gets to be an issue, but what happens when everybody in Africa, India, and indeed within the tropics switches on their air conditioning because the climate has warmed by 5 degrees Celsius overall? We have to deal with that somehow. On the front for getting away from fossil fuel, I will note that Germany now seems to be installing more solar panels than pretty much the rest of the world combined. Scotland is on course to be 100% powered by renewable energy within another 5 years. We've got a lot of tide power and wind power in Scotland, even if solar power sucks in winter. 6 hours of daylight.
Still need rain power though, then we'll have it now.
Yeah, yeah. And an interesting piece of news is that South Korea, a couple of weeks ago, announced government funding for a prototype fusion reactor that will be providing base load to their national grid within 15 years if all goes well. Yeah, they've decided to jump the gun. Japan is very conflicted over nuclear power, especially post-Fukushima, but South Korea has very much the same lack of natural resources, no coal or gas to speak of, has to import all their energy supplies, and they seem to have decided to go whole hog for fusion power as the solution. You say?
So are they, is it not part of the ITER program?
They are part of ITER,
Okay.
but they have jumped the gun, and rather than waiting for ITER to
Oh,
wind up,
okay.
they're
That's
going to
interesting.
leapfrog it.
Okay,
And
that's cool.
the worst case is they make some very, very expensive mistakes. The best case is they have a 1 gigawatt fusion reactor providing base load within 15 years, and actual production reactors another 15 years after that. So, what are we looking at for the mid-21st century? Well, we're not going to be dealing with personal jetpacks or flying cars, for which I'm very, very grateful. Personal flying cars and jetpacks sound like a really great idea until you imagine your neighbour's 16-year-old son borrowing the family jetpack or flying car to impress his girlfriend. And bear in mind what the failure modes for any aircraft are, and he's straight up there. You don't want him to have a jetpack or flying car, and you know, if the price is that you don't have one either, that's a price worth paying for not being rained on by demented 16-year-olds.
I'm clearly familiar with driving in Boston.
Well, yeah. Think of it as Boston driving in 3 dimensions with drastic failure modes. You know, for some technologies, we're better off leaving in that imaginary box with the Jetsons. You know, we don't actually want them in the real world. Arguably, anything that... Well, I was going to use anything that makes nuclear weapons particularly cheap as an example of that, but you know, nuclear weapons are basically 1940s technology. The North Koreans can make them. The Iranians can make them. I mean, this is not rocket science. Well, no, rocket science was also a 1940s technology.
But not as big.
Yeah.
The car.
One of the interesting points about these technologies is that the further back you go with the technology, historically, the longer it took to see widespread adoption. Steam locomotives. Steam power was first really deployed in raising water from flooded coal mines in the 18th century. It took until the early 19th century for locomotives to actually be light enough and mobile enough to pull on rails and move around. And it took another 50 years for them to become a ubiquitous form of transport. Again, the telephone took sort of 50 or so years to take off. Television, 20, 30 years. But technologies are coming thick and fast. And can I ask for a brief show of hands? How many people in this room have a smartphone, be it an iPhone or an Android or something similar? Virtually, ooh, I see somebody who isn't raising a hand. Okay. Maybe 10% don't. These devices, I got my first smartphone because I'm an early adopter and an idiot. Around 2002, 2003, it was a Palm Trio. But the touchscreen ones we're all familiar with, which have really taken off, only really appeared in 2007. So in 5 years flat, they've reached 90% penetration of this sort of audience, a tertiary higher education sector audience. And these are really the first truly personal computers. Earlier PCs, up through the laptops that various people have here, are still sort of your large monolithic computer that has shrunk into a portable format. Whereas mobile phones, particularly smartphones, are designed to be person-centric. They're designed to support everyday applications and absorb a lot of other everyday functionality. Bruce Sterling has a riff about this. He refers to iPhones as being cannibals. iPhones have cannibalized a lot of other gadgets. They started with the mobile phone, but an iPhone is not a mobile phone. It is a compass. It is a GPS system and a car sat-nav unit. It is an FM radio, a bit more than that actually. It is a web browser. It is an email client. It is a pager. Trying to remember what else you can do with it these days. But
So even when I got my first regular phone, I stopped wearing a watch.
yeah, it's a Swiss Army knife of electronics. I mean, I am one of those people who no longer wears a wristwatch because I have a phone.
Yeah.
Now, where was I going? These devices are already on the way to achieving global coverage. And I would say within another 5 years, more than half the population of this planet will have something roughly as powerful as an iPhone 5. Because they're getting cheaper, they're spreading, the Chinese manufacturers are getting involved. Infrastructure in the developing world supports internet over wireless much more easily than it supports internet over wires that have to be strung. Because, you know, people who get infrastructure late get better quality infrastructure than the early adopters. The United States, for many decades, put up with an abysmally poor quality colour television system because you got colour television in the 1940s, late 40s, a decade before anybody in Europe did. The result was the systems that got rolled out in Europe were generally better quality, but we got them later. Similar things happen with telephony. People who install telephone infrastructure later get better service. Again, electricity systems. Great Britain was largely rewired in the 1940s after World War II, and the result is we have a fundamentally better system of wiring up households based on a ring main with individual fused systems in every single mains plug, not to mention circuit breakers at the circuit box.
So you have to admit that's a pretty awkward reason to have to build new infrastructure.
Yes, a lousy reason to build new. Well, you know, actually, if you want to build new infrastructure, nothing helps like having the Luftwaffe bomb you flat for several years. But, yeah. But one of the side effects of China, India, and Africa developing will be that they get better infrastructure than we did. Consider the Chinese high-speed railway system, for example. It was built cheap, there are an awful lot of bribes paid, there have been some train crashes, the concrete is of poor quality, and the trains are consequently limited to running at no more than 185 miles per hour. While they fix the network so they can run at their true design speed of 220 miles per hour. This is what you get if you develop late, instead of Amtrak. So, one of the side effects of this is we have, in the United States and also in Western Europe, a big problem with installed infrastructure which is aging, a political culture which, to put it bluntly, really doesn't like paying money to maintain infrastructure if instead they can line their own pockets with it. And sooner or later, we're going to have to replace a lot of our infrastructure. In the meantime, we're going to be trailing behind the newly developed nations once they have achieved, effectively, developed world status. So I would say the shape of the world in 2040 is one that will not be dominated by Western Europe or the United States, the traditional developed world powers. It probably won't be dominated by China either, because their demographics by 2040 will look a lot like Japan today. A lot of very elderly people and not enough workers working to support them. So, to some extent, economic stagnation and possibly even a deflationary spiral. Who will be leading the pack? I can't really predict that at this point. Now, other things that we can expect in 30, 40 years' time. Moore's Law. Anybody here not heard of Moore's Law? I see a hand or two go up. Okay. Moore's Law, Gordon Moore, CEO of Intel, if I remember correctly, in the 1970s coined this law. It applies to semiconductor fabrication and, loosely, integrated circuits, the cost of a given electrical circuit on a semiconductor halves every 18 months. Alternatively, the area of semiconductor required to accommodate the circuit shrinks by a factor of 2 every 18 months. Basically, everything doubles every 18 months. The number of transistors you can get onto a given slab of silicon doubles every 18 months. Because we're basically dealing with a photolithographic process of etching increasingly small circuits, and we're basically getting better at it. This law was basically an empirical law based on observation of how improvements in photolithography were driving things. It's not a law of nature, it's effectively a law of engineering. It is going to end, and it is going to end, well, people have been predicting the end of Moore's Law for a couple of decades now. I think we can safely say that you can't make an electrical circuit where the circuit tracks are narrower than 1 atomic width. So, on that basis, it's got to end within about 10 or 15 years anyway. although we may see three-dimensional stacked circuits, at which point we run into issues of heat dissipation. But I think we can say by 2043, one way or the other, Moore's law will have ended, much as the earlier sigmoid curve of technological development ended, which was transportation speed. In 1813 or thereabouts, there were no real regular scheduled railroad services anywhere in the world. Trains did exist. Locomotives, they were mostly used for hauling coal out of coal mines. Nobody had actually built an actual full-service railroad at that time, although they were trying to. Consequently, the fastest anyone could travel was on horseback at a gallop for a short distance, and for serious sustained transport, it was either by ships or stagecoach at about 8 to 10 miles per hour. By 1970, you could get from one end of the planet to the other, say from Great Britain to New Zealand, the Antipodes, in 48 hours. In 1830, you could get from one side of the English home counties to the other in about the same time, by stagecoach. The entire planet had shrunk to the size of Massachusetts, in effect, in terms of human travel time. That is, you could cross the entire planet in the time it would have taken you in 1813 to cross Massachusetts. What happened was a series of cascading technological developments, starting with the railroads, followed by the application of steam power to ships, also the internal combustion engine, aviation, and we saw a massive increase in the speed of human transportation from about 10 miles per hour by stagecoach or ship to 100 miles per hour by railroad by the end of the 19th century, and then to 500 odd miles per hour by commercial jet service by the 1960s, to the fastest human beings have ever travelled, just over 25,000 miles per hour by one of the Apollo crews on their way to the moon in 1970, if I remember correctly. And no human being has ever travelled faster than that since. What happened is Newton's law of motion comes into play. Kinetic energy of a moving object is proportional to half its mass times the square of its velocity. Hang on, have I framed that wrong?
Yeah.
No, that's
It's
right.
half of v squared.
Yeah, basically v squared. Kinetic energy goes up as the square of the velocity. The flip side is to square your velocity. Well, to increase your kinetic energy, you need to put in to increase your velocity, you need to put in a massive increase of kinetic energy. Other problems have cut in which have stopped us travelling much faster on Earth, which is to say friction, atmospheric friction, air resistance. The reason jet airliners today travel slower than they did 20, 30 years ago is because fuel economy is more important. Shaving 100 miles per hour off the speed of a subsonic airliner will save you 50% of its fuel bill. So this brought the sigmoid progression of increasing transportation speed not to a screeching halt, but to a gentle climax after about 150 to 200 years of progressive incremental improvements. We are in a similar sigmoid curve with the performance of our electronics. Within another 30 years, it is going to be very difficult to get any serious performance improvements out of semiconductors. We're going to be running into problems of heat dissipation if we're stacking circuits vertically. And we won't be able to make anything much smaller. On the other hand, there is another law, less well known than Moore's law, that comes into play, Kuhme's law, which was coined relatively recently by, I'm trying to remember his first name, a physicist at MIT, if I remember correctly. He basically pointed out a very interesting countervailing trend that goes in step with Moore's law, roughly, but every 15 months, the energy demand for a given electrical circuit on semiconductor is halving. Now, that's a really interesting one because it suggests that while there's a limit to how small we can make our circuits, we can claw back some extra headway by reducing the energy demands per unit of per computation. Kuhme's law is also going to come to an end eventually. you can't actually do any useful electrical, you can't do anything useful with electrons if you don't apply enough energy to kick an electron out of an orbital on one atom and onto another one. So there is an actual flaw to how low you can go in terms of power. There's a further flaw, a further limit, which is actual thermal noise. But we are still several orders of magnitude away from maxing out on energy efficiency of our circuits. What happens if you put Kuhme's law together with Moore's law? Well, you basically get to a stage where in about another decade, we should be able to make circuits about as powerful as one of today's smartphones. In other words, an ARM core able to do about 1 billion operations per second, on the order of 1 billion operations per second, but will be run off for about the price of a radio frequency ID tag for a store inventory controller today, namely under $1, and that will consume a small enough amount of power that you can in principle run it off solar, ambient solar energy with a surface area of a couple of millimeters square. I ran the figures on this. If you really want, I can dig them up. But we're talking about very low power circuits running off ambient sunlight. How do they communicate? Well, there are, again, radio frequency communications to neighboring chips. If you're looking at a range of centimeters to tens of centimeters, it's practical to run them off, if not picowatts, then certainly nanowatts for burst transmission. Now, it gets very interesting when you start asking what you can do with such cheap circuits. A back-of-the-envelope calculation I came up with suggested that you could pretty much wallpaper large cities with them at an average spacing of about 1 meter per microprocessor. London currently spends about 120 to 130 million pounds a year scraping chewing gum off sidewalks. The cost of paving London with circuits with this cost of roughly $1, one microprocessor per square meter is a bit less than they pay per year on removing the chewing gum. So the question is then, given all the sensors we build into our mobile phones, compasses, we could easily put thermocouples in, it's got cameras, well, the cameras are going to be limited with the size of the chip. What can you do if you can network an entire city with sensor nodes at a density of 1 per meter? Furthermore, what is it going to be like to live in such a city? I'm going to ask you this now as something to just take away and think about, because it's probably coming within 10 to 15 years, wherever you live. Answers I came up with, just trying to brainstorm them, start with self-driving vehicles. It would be really useful if your self-driving cars, the Google-mobiles, aren't simply following a street map and GPS, and aren't simply using their own sensors to detect obstacles, but are guided by an active road network that is monitoring events in front of them and can notify them of impending traffic hazards. For example, the 4-year-old who is about to chase their puppy out into the street just around the corner that the car's driving towards. Again, monitoring patterns of human behaviour. Human beings do tend to behave fairly predictably in public spaces. If a human being is walking around and they just fall over and land on the sidewalk, then you might want to actually dispatch an ambulance to get to them because they've gone into cardiac arrest. And it would be useful if the sidewalk itself could call for help. Again, getting more speculative now, genome sequencing is one of those technologies which is going through a massive period of improvement right now, thanks again to Moore's law. Most of the technologies needed for conducting shotgun sequencing of DNA using polymerase chain reaction to amplify small samples of DNA are intimately dependent on integrated circuitry and indeed on micromachining technologies. We're currently seeing DNA sequencers coming on the market this year that should be able to sequence the entire human genome in about 36 hours at a cost of about $10,000. Okay, putting the genome together from all the fragments is going to take a week of supercomputer time, but again, the price of supercomputer time is dropping as well. extrapolate far enough, and wouldn't it be interesting to be able to shotgun sequence the entire microbiological genome of a city in real time? To keep an eye on, for example, what ponds have Legionella breeding in it, so that we get advance warning before an epidemic strikes. So, for example, if there are signs of West Nile disease kicking around, we can go and preemptively treat the pond that is infected, where the malaria parasites are breeding. Sorry, not malaria parasites, where the mosquitoes are breeding that carry West Nile disease. The civil rights and privacy implications and policing implications of ubiquitous surveillance should be absolutely glaringly obvious, and this is essentially a political problem that the politicians haven't woken up to yet. If you think today's issues to do with privacy and monitoring on the internet are bad, wait until it erupts into the real world. The final thing I think that we can think of as an aspect of this is it makes an actual positional internet practical, one where we can associate metadata with physical locations easily, where there are computing nodes everywhere that can act as reference for stuff, where we have metadata tagging of objects in the real world that also exist in the internet as Bruce Sterling would call them, spines, where we can basically keep track of everything in our environment around us. Anyway, we're going to get that level of technology a long way before we get to 2040, and this is the world that you people are going to be shaping as well as living in. It's going to be a very strange world. It's going to be a world where the normative person is not living in a dirt hut in the developing world, but is actually a developed world citizen, where the average life expectancy at birth is on the order of 100 years. Everything we do is monitored, in many cases to our own benefit, so that if you have the proverbial sudden cardiac arrest while out jogging, you will be rescued. And it is a world where ubiquitous computing is available if you can think of things to do with it usefully. And at this point, I've sort of run out of my canned rant. I've been talking for 35 minutes, so I should actually throw it open and ask the questions. You got your hand up first.
Okay, I have a couple.
Yeah. Just one at a time, then we'll go around a bit.
Okay,
Yeah?
then one was just interested in, so do you think that problem of, when you start reducing a population, then the proportion of workers to a new population, and that leads to sort of a poor economic situation, do you think that means that it's sort of economically infeasible to slow the rate of population increase?
That's a very interesting one. It's not unfeasible, but it does mean that it is very, very difficult to put the brakes on fast. Population pressure has a very, very long lag time between cause and effect. The Chinese one-child per family policy came in the 1970s. They've finally begun to relax it. The result is they currently have a young, highly skilled workforce hitting the peak of their ability. They're in their early 30s for the most part, but behind them, far fewer children. As the current 30-year-olds age, in 30 years' time they're going to be 60-year-olds, and you've got a much lower ratio of workers to people who are active in the population. Now, this isn't necessarily a bad thing. With increased automation, we may well be able to maintain levels of output and productivity while looking after a much higher proportion of retirees. But it does mean we have to make serious consideration of the effect of changing demographics on society. We're seeing it to some extent in the developed world already, where the idea of being able to retire at 65 is pretty much going out of the window. We're going to have to work longer. Yet at the same time, we don't have enough jobs to go around to fully utilise people. And it's only going to get worse. An acquaintance of mine is of the opinion that an increasing number of people are now functionally disabled in terms of employability, because they simply cannot do anything useful that can't be automated. Every time you see a street sweeping machine go by with one man there operating a vehicle with brushes that sweeping a sidewalk, that was a team of guys in the old days with brooms. And, the guys who can only push the broom and can't drive the vehicle are out of a job for good. This is getting worse as we automate more and more functions of intelligence. Take, for example, Google Translate. they've been working on statistical methods for translating documents from one language to another, and they're getting progressively better. They still haven't made translators obsolescent, but there will come a point at which translation becomes, well, mostly machine assisted and a matter of editing and polishing what the machines have done, at which point you've just engineered a highly skilled job. How long does it take to learn a foreign language? Pretty much out of existence. There are going to be a lot more occupations like this. If Google's self-driving vehicle initiative does deliver, then the long-distance truckers, the taxi drivers, they're going to be out of jobs. Your own job of driving your own automobile to and from work will go out the window eventually, once the insurance companies become convinced that self-driving vehicles have a lower accident rate than drivers.
Which, you know,
You'll be priced out. You know, you may have a steering wheel in your car for taking it to a track day for racing, but you won't be allowed to use it on the open road. And the good thing too, because about 90% of fatalities and accidents on the roads are due to human error. But yeah, the problem we've got is we are in danger of finding out the hard way how many of our jobs can be automated out of existence.
Sorry.
Yeah?
On that last one though, there is the famous phrase, to err is human, to truly screw up requires a computer.
Oh yeah, I'll grant you that one. But yeah, we do have a political problem to some extent because the whole industrial age, since the 1800s, has been predicated on the idea that you work or you starve, that work is somehow not only good for the soul, but necessary, that the devil makes work for idle hands. We're going to have to find out what to do with an awful lot of idle hands over the next 50 years. Next question?
So earlier in your talk, you commented on, a class of technologies that would perhaps facilitate the proliferation of nuclear weapons as things that, might not be worth looking into. However, going along with the MinION sequencer, which is now allowing for low-cost shotgun sequencing, the technology is going to swing the other way, and we're going to be able to produce DNA.
Yes, we already can. New scientists a couple of years ago did an experiment. They sent up to some commercial labs who will provide sequences of RNA and DNA on demand. And, well, they were doing it as an experiment, but yeah, they got back sequences of multiple hundreds of bases of the RNA for smallpox. There's a happy fun thought for you. Luckily, terrorism is an overrated threat. In general, politically motivated terrorists are stupid, or they are facing a totally obdurate, recalcitrant enemy who will not respond to anything else. The point being that if they're facing an enemy who are willing to negotiate at any point, then the smart ones will turn politician and negotiate. What you're left with are either the no-hopers or resistance movements against totalitarians. Where was I? Yeah. No, I was actually saying the thing about nuclear weapons is we don't really want to encourage technologies that make it easy to kill large numbers of people, but I'm afraid we're getting them. Something recently showed up on Alibaba, the commercial merchandise website for buying large quantities of objects from China. Remotely piloted military drones!
Yeah, saw that.
Not up to the standards of General Electric or McDonnell Douglas, but hey, it's a drone. You too can buy one in a shipping container from China. Sorry, but yeah. Other question? You said.
Yeah. So a lot of things have been automated. Where do you think the idle hands have gone so far?
A lot of it has been sucked up in people who are eking out desperate marginal existences on part-time work. We also have an issue with people being overskilled for the jobs that are available, because one of the interesting phenomena that's going on is the jobs that are hardest to automate are those that involve personal face-to-face contact. Carers, nursing, personal cleaning, looking after elderly folks in nursing homes, being a short order cook at a McDonald's. These are paradoxically a lot harder to automate. And indeed, those jobs that require personal service jobs are going to be the last to go, in my view. These jobs also tend to be predominantly occupied by women, by ethnic minorities, and they are underpaid and undervalued by society. They're also labour intensive. So what we are seeing to some extent is de-skilling, many people who are overqualified occupying jobs that don't utilise them effectively. Many other people whose jobs can't be automated are not being rewarded very well for what they're doing, and a huge squeeze on what the skilled working classes and the middle classes, and especially the professions. One current issue is the bubble bursting in law schools in the United States. For many years, indeed for decades, a law degree was sold as your ticket to a good living. Unfortunately, along come the likes of Google, the search technologies, and jobs which used to employ an awful lot of low-level lawyers, namely legal research, have been automated out of existence. Result is that the senior lawyers don't need the juniors to help out anymore, and first unemployment spiked among recent law graduates, and then number of students entering law schools has begun to collapse in the past year or two. And this is symptomatic of stuff that's going to happen to a lot of other professions. It would not surprise me in the slightest to find that accountancy and tax preparation was next up. One of the things that's overdue is for the IRS and their foreign equivalents to automate a lot of the tax accounting systems.
Please.
I mean, it's pretty close, right? Like using
Yeah.
TurboTax versus hiring someone to do it
Exactly.
for you.
And once you get into that territory, there'll still be niches for accountants, there will be specialists, they will be catering to high-end customers who really need to find interesting loopholes.
Or just edge cases.
Yeah.
As someone who,
Or edge
like you,
cases.
pays tax in more than one, has paid tax in more than one country.
Oh, I pay tax in only one country. I'm a non-resident alien in the United States. I like to keep it that way. It's bad enough dealing with the British tax authorities. But yeah, it's a very worrying question, what we're going to be doing in the future. One thing I will advise you on is don't expect to have only one career or one profession. If you're in your 20s today, you're probably going to go through 3 or 4 professions, and you may actually run through them in parallel, not just one at a time. Because you might be working as an engineer by day and stacking shelves in a Walmart at night to make ends meet if things go as badly as they could in some scenarios. I'm hoping it doesn't get that bad.
So I guess we're kind of talking about post-scarcity to some degree, and it kind of breaks a lot of economic models.
It
And
doesn't.
there's a lot of political issues to be resolved
It
with.
doesn't necessarily break Keynesianism. Keynes himself actually speculated about when we would achieve an effective post-scarcity society. Back in the 1920s and 30s, his proposal was that by the 60s we should be able to reduce the working hours per week to about 10-15 hours per person. And he was absolutely right. The problem is we reduced it to 10-15 hours per week on average, with some bastards having to work 60 hours a week, and a lot of people being unemployed. The solution to this is fundamentally a political one. How to get there from here? Well. And I will furthermore add, every politician I have met has been an intelligent person who meant well, but they're working within a system. And one of the problems we've got is perverse incentives built into our systems. Other questions?
So we talked about hardware limits of technology, and just in general more broad, those sorts of laws. Particular thing that I'm intrigued by is we talked also about infrastructure, and we didn't talk about limitations on infrastructure. So 2 cases in particular is obviously the wireless.
Yeah.
You've got a Shannon limit in all your frequency spectrum, and we can keep up pushing the spectrum to so-and-so, but the noise floor will hit us at some point.
Yeah, on the other hand, smaller and smaller cells are one way to get through that. And if instead of going for radio wavelengths, you go for optical networking, if you think in terms of optical frequency or even terahertz transponders built into the light fittings here, we could cram an awful lot of bandwidth in. Another issue is using wired or fiber infrastructure as backhaul between cells.
So, Thank you very much. That's good suggestions. What I was really wanted to ask you about though
Mhm.
is do you think there's any possibility at all for changing some fundamentally how we might do infrastructures? So we've developed, for example, this giant code base that's all developed whenever programmers are coming out now. People don't really learn C anymore. People don't learn assembly anymore. And that's part of the reason that we need to keep making devices more and more efficient is because nobody writes efficient code.
I think we're going to have to see a trend towards writing efficient code once Moore's law begins to tap out. At that point, that will be the only way to get performance improvements, better code. So, I don't think we've heard the last of that. I've got a CS degree from 1990, which means I'm qualified to talk about computing like an aerospace engineer with a degree from 1937 is qualified to talk about Concorde. But I've been sort of out of the programming trade for over a decade now, and just looking at the trends in modern programming languages that have come along and software engineering methodologies makes me feel very primitive indeed. I've been working, I learned my trade on these biplanes with propellers and what are these strange jet things? There's a lot of room for further progress in that area. And yeah, we will see more pressure for that level of progress coming up. And I'm seeing some signs of it on a sort of hobbyist basis. The Raspberry Pi initiative encourages people to program on low-end devices at a fairly low level. That's the whole point of it. To provide a computer which is also a simple enough device for somebody to get their head around. Because one of the side effects of having really enormously powerful microprocessors is they're enormously complicated. A modern ARM processor, never mind one of Intel's high-end core designs, dwarfs in complexity an early 1990s Cray supercomputer. It is useful for programmers to learn on constrained systems which are actually small enough to comprehend. Further questions? I think you had your hand up first. Yes, you.
So, with the rise of globalization and all that sort of stuff, do you see the traditional territory boundaries remaining the same over the next 30 years, or is it do you think most nations are going to stay nations? Do you think they're going to conglomerate? Do you think it's
I am wishing I had my peaked hat with a hammer and sickle on it at this point, because it's here that I get tempted to start standing up and spouting communism. One of the interesting things about free trade is that it is relies on free movement of capital to seek the cheapest labour, but at the same time, free movement of labour? Well, we've heard about those Mexican immigrants and we don't want them here, and the Prime Minister in London is ranting about how he really doesn't want Romanians there. Do you know that the British government is currently preparing an advertising campaign for Romania and Bulgaria, who joined the EU a while ago and who will be acquiring free movement within the EU, to persuade Romanian and Bulgarian workers not to come to Great Britain looking for work? They're not allowed to legally exclude them anymore, so they're going to do advertising campaigns to persuade them they don't want to go there. The language of populist racism, to put it bluntly, and anti-immigrant sentiment plays very well with the interests of arbitrage of labour, of trying to send raw materials to the places where they can be turned into finished products cheapest. However, this relies in turn on differentials in wages. And one of the interesting things about the Chinese and Indian revolutions, as they develop, is that the labour becomes more skilled, it costs more. It is difficult to move your call centre to Bangalore these days because there aren't enough people there who are capable of doing the job, who don't already have a high-paid job, and they're not that much cheaper. It's hit the point where Apple are apparently rumoured to be moving a manufacturing plant for one of their computers back to the United States. It'll be heavily automated, but it's economically viable to do so rather than keeping it outsourced to China. So in the long term, as the world develops, we're going to see less of the wage differentials that allow for globalization, and ultimately it may be this results in a relaxation in the controls on free movement of people. But right now, if I wanted to come and live in the United States, it would be very difficult indeed for me to emigrate here. There is one loophole that gives you pretty much free emigration rights anywhere on the planet, though. I'll tell you for free what it is. It's $1 million in cash. Because you can just walk up to any country, hire yourself an immigration lawyer and say, I want an investor's visa. And you'll get it. Everybody likes cold cash.
So on the other end of free movement of labor, so you mentioned that the Western world might become, might get exceeded by somebody else. Do you think that since the Western world currently benefits a lot from brain drain from the third world, the developing world, do you think there might be a reversal of that?
The brain drain's already to some extent gone into reverse. There are a lot of people who've come over here or to Europe to get an education and then get ahead are finding that with what they've learned and also with the resources they've acquired over there, they can go home wherever they came from and set up well. There was an interesting phenomenon that is sort of a microcosm of this in Edinburgh, in Scotland, where I live, in the 1990s. In the late 1990s in Edinburgh, I was working for a .com, and we realised after a while that we really ought not to have bothered. We should have studied plumbing. Because plumbers in Edinburgh could earn more than Java programmers in the late 90s. Then Poland joined the EU, the Poles acquired free movement within the EU, and the price of plumbers dropped by 70% in 2 years. Because, the Polish government is largely elected by this bizarre coalition of rural villagers, peasant farmers, and the Catholic Church. And young people really don't like that kind of thing. They want to get ahead, they want to move somewhere, earn a chunk of money, and a lot of the young, energetic Polish workers, the energetic ones, upped stakes and headed for Germany, France, Great Britain, anywhere they could earn money. And for a while they were overrun by cheap plumbers and builders, and it was wonderful. You could get your toilet fixed without making an appointment 2 months in advance. Only a few years later, a lot of them began going home again. Because they had been earning at British wages and British rates, and that money would go a long way in Poland. They could go home, they could start their own business.
And the new Polish government is more liberal.
That too.
Even has a trans woman in it at the moment.
Yeah.
So it's...
So you get these ebbs and flows and reversals of immigration. An interesting point to make about this is, if you go back to the 19th century or even up to the 1960s, the cost to an emigrant of moving to another country was enormous. Britain in the 1950s had this subsidised scheme to get white Britons to move to Australia, subsidised by the Australian government as well. They would sell a ticket on an ocean liner to Australia for £50, about equivalent to $1,000 at today's rate, for 6 months on a liner. Damn it. No, was it for 6 weeks? Something of that time, a long time. And if you'd spent 6 weeks to 8 weeks on a liner, gone to another country, you'd have a good incentive for just staying there, because the pain of trying to go home, you're talking about a 3-month round trip. Today, it's 24 hours. Also, the price has sunk by an order of magnitude, because cheap jet travel is cheap. So, I've got a working theory that what previously people would have emigrated for good, made a new home for themselves in a new land, today they may go somewhere, work for a few years, and then go home again, because they can. I'm a very lazy, untidy person, so I pay a cleaner to come around every couple of weeks to clean for me. She's Hungarian. Every few months, the housekeeper can basically afford to fly home 1,000 miles just to go home, see her family. She's not making a permanent home in the UK, because if you go back a century, that would have been a really daunting journey. It would have taken her a month or more. So she would have moved permanently. So we're seeing a different pattern of migration these days to what it used to be like.
So it's 7 o'clock, so we're...
Okay, we should wrap it up at this point then.